Okay, now we are going to learn about the operations on matrices. The first of all, always you learn about addition. Addition is the favorite. So first is about addition. So how do you add two numbers was the thing you learned in primary classes. Here you are learning addition of matrices. Okay, there is always a condition while it comes to the matrices. When it is a matrix, if you need to add two matrices, they should be of same order. Okay, if I consider A, it should be of 3 by 2. If I need to add with some B, then B also should have that order, that is 3 by 2. So you found A, it should be of the same order, A and B should be of the same order. If you add, you are going to get another matrix. Say I'll call it to be C, that is of the same order. It should be of the same order. That is the rule of the addition of matrices. So if you are going to add two matrices, you are going to add everything. That is, if I consider Aij is one of the elements, is a general element of belonging to this set, and Bij is going to be the general element that is belonging to this set, then it should be equal to the general element that is belonging to the set C. If it is going to be correct, if A plus B is equal to C, then I can tell that the general element of A plus general element of B should be equal to the general element of C. Or I can tell first, maybe if the first element first row plus first element first row should be equal to the first element first row of A, B and C respectively. So if I have some matrix like 1, 2, 2, 3, this is A, and if I have B, that is 2, 3, 2, 3, okay, then what will be the matrix C is 1 plus 2, 3, 2 plus 3 is 5, 2 plus 2 is 4, 3 plus 3 is 6. This is going to be C. That means that every element should be based on this general statement, that is 1 plus 2 should be equal to 3, 2 plus 3 should be equal to 5, 2 plus 2 is 4, 3 plus 3 is 6. That should be followed. That is what the matrix addition tells. That's it. So that's all about addition in matrices. So next thing about matrices may be about multiplication. First multiplication, we'll learn about multiplication by a scalar. Multiplication by a scalar. What is a scalar? Scalar is something which has only magnitude. Your reference when you are considering vector algebra, we have one more chapter, vector algebra. So when you consider that, you have two types of things, that is vector as well as a scalar quantity. Vector quantity has something like which is having direction also along with the magnitude, while scalar is something that has only magnitude but no direction. Okay, that is a scalar. So if you consider a magnitude, it can be any real number. So maybe I'll take root 3 as one of the real number. So root 3 is a scalar over here. If I have, maybe I'll take the identity matrix here itself. So it is going to be 1 0 0 1. So if I have to multiply root 3 by this matrix, so this becomes root 3 into 1. This is root 3 into 0 is 0. Root 3 into 0 is 0. Then root 3 into 1 is root 3. So root 3 times that matrix. So this is one of the identity matrix. So it becomes easy for you to understand. That's why I took an identity matrix. If I multiply root 3 by this, I need to multiply every element of this matrix by root 3. Okay, you need to think properly. Here, every element you need to multiply by root 3. But this is not case in the determinant. So you'll be learning in the next chapter. So you should not get confused with this. So when you multiply 1, so root 3 into 1 0 0 1 is equal to root 3 0 0 root 3. This is going to be in this form. So if I multiply by any number, any scalar by the matrix, all the elements should be multiplied by 3. If I consider it is going to be the element 1 1 1 1, this is the matrix, and I'll multiply it by 2. 2 is one of the scalar. Then it forms 2 2 2 2. That is what you are going to get. That means that every element should be multiplied by 2 in order to satisfy that multiplication by scalar. So there are a few properties which you can learn from this scalar. One property is about negative. So when I'm talking about scalar, I can also tell that it is going to be negative. If I consider this was a real number I had taken. If I take minus 1 into a, I can represent it as minus 1 into a, or directly I write minus a. If minus a, in the first case I'll take, first case it was 0, so it was minus 1. Minus 1 into 0 is 0. Again here also 0. Here it's going to be minus 1. So what is minus a is called to be the negative of this matrix. This is the negative of the matrix. So why have we found out this negative of the matrix is to define what is subtraction of matrices. Okay, what do you mean by the subtraction of matrices is, if I consider one matrix, okay, we consider one matrix, so A minus B you are asked to find out. So we need to find the difference between the two matrices. Difference if A set is 2, 3, 3, 2, this is one matrix, and B is a matrix with minus 1, minus 2, 4, 3. Okay, this is going to be like this. So what does this A minus B mean? I can just represent it to be A plus minus B. Okay, this is the same, this is going to be the same. If I write 1 minus 2, it is same as 1 plus minus 2. That is the same thing I can write here. So it is going to be A plus minus B. So how do we do this? So first of all you need to find minus B. Okay, for that we'll just write A here, that is 2, 3, 3, 2, and adding is very simple, right? So you have minus 1, so I need to multiply minus 1 by each element. So you have minus 1, minus 2, 4 and 3. So minus 1 becomes 1, minus 2 becomes 2, 4 becomes minus 4, 3 becomes minus 3. Okay, now the remaining thing is all about addition. So if I need to add, it is going to be again a 2 by 2 matrix only. So 2 plus 1 is 3, 3 minus 1, 3 minus 4 is minus 1, 3 plus 2 is 5, 2 minus 3 is minus 1. This is going to be the answer. So if I consider the difference between A and B, I need to get this as the answer, that is the matrix. So even if you don't do this step, you can directly find out this by putting a minus sign here, and directly you can do 2 minus of minus 1 is 3, 3 minus of 4 is minus 1, 3 minus of minus 2 is 5, 2 minus 3 is minus 1. See, directly you got, instead of doing that very long method. So if you're just asked, if you are given, you need to find the difference between these two matrices, directly you can do this. If you are asked to prove how it has got like this and all, you need to give that stepwise explanation. Okay, next we'll learn about the properties. We are going to learn about the properties of matrix addition now. So matrix addition, first of all, when you consider the properties, we always talk about the commutative law. Commutativity or commutative law, we are already learned in while telling about the binary operations and all. Since this is operation on matrices, this is going to be a binary operation again. So if you have A plus B is always equal to B plus A. Therefore, it is a commutative property. So the second one is associative law. Associative law. So generally we just want the meaning of what is given, because even if you consider the textbook, they are given big examples of how it is going to come, how it is coming here and there and all. So now we have associative law. If you consider three matrices A, B, C, I just write the associative law, that is A plus B plus C is equal to A plus B plus C. So this is going to be the associative law. So this holds good for matrices, therefore it is going to be the associative. So the third one is about presence of identity. Identity exists. In the relationship functions, we found that if you consider E as identity element, then A star E should be equal to E star A, that should be equal to A. So if you consider, this is the addition, right? So if I consider this to be the E to be the identity, and we consider the general matrix A, then A plus E should be equal to E plus A. Because it is commutative, this condition is going to be, however, true. So it should be also equal to A. Should be also equal to A. Okay, if we consider only one of these cases, so A plus E is equal to A. So you can find out that if you add, so maybe I'll take an example like 2, 2, 2, 2, and this is going to be some 2 by 2 matrix only for the example. So at last you are going to get 2, 2, 2, 2. So you need to add some number for which it is going to be the same, that going to be always 0. Therefore this represents 0 matrices of a particular order. Depends on the order of A over there. If the order of A matches with that of the order of the 0 matrix, then it is going to be the identity. Therefore 0 represents the additive identity. Additive identity. Okay, now we have a fourth. If there is an identity, the elements should have inverse. That is, when A star B is equal to E is equal to B star A. B star A and A star B are same because it is commutative. So I need to take only one of them. I'm talking about the inverses. So if I take A, inverse of the element. So I'm talking about additive inverse, not the inverse of the matrix. I need to just check. It's the additive inverse of that. So if I have A and maybe one more element B, it should be equal to 0. That means that every element of B should have opposite signs of the elements that is present in A. So if I have A to be 1, 1, 1, 1, then B should be minus 1, minus 1, minus 1, minus 1. So that its addition is going to be 0 matrix. Therefore, B can be written as minus A. Minus 1 into A or minus A. That is a negative of A. Therefore, minus A is the inverse of A for every A. For every A, that is a set. Okay. Next, after this, we are going to learn about the properties. First of all, we had learned about matrix addition, right? Now we are going to learn about scalar multiplication. Properties of scalar multiplication. After doing this, we are going to the exercise. So it's about scalar multiplication. What is scalar multiplication? You are going to multiply by some scalar. So what could be the properties of such things? So if you have like k times the sum of two things, that is going to be k into A plus k into B. So if you're considering this multiplication is distributive over that, matrix addition is what you're going to learn here. Okay, that is what we learn. So if I have k into A plus B, we are going to get k into A plus k into B. So if I, in the opposite way, if I have k plus L into some matrix A, so this also you can make it as ka plus La. This here it was A plus B. The matrices were added here. Here only the number, that is a scalar, is going to be added. If you consider this as one more case, then it is, you can write it in this form also. Okay, those two things you can directly prove if you want. Proof is given in the textbook. You can just check how it has come and so many things like that. Okay, that's it all about the properties of this thing. Then we learn about the multiplication of matrices. Multiplication of matrices. So till now we learned only about scalar multiplication. So now we consider matrix by a matrix. Okay, we need to consider matrix by matrix. So there are conditions when it comes to be matrix. So matrix multiplication. Matrix multiplication is a very important part you are going to learn here. Okay, you need to learn this very properly because you are going to get questions on inverse where you need always matrix multiplication. That is very very important. So see properly. So if you have A into B, what is the condition for which A can be multiplied by B? So if I consider A has an order of m by n and B has an order of n by p, yeah, only then A can be multiplied by B. What do we find out in this? The speciality here is n is here n. So the number of columns in A is going to be the number of rows in B. So in such a case, what will be the product that we are going to get? Product, let me consider to be C. What will be the order of that? So for that, we need to leave out this 2n. So it is going to be m by p. M by p. So when you multiply, you can understand how the order is going to change. That means that n and n is here. So that n vanishes and only m by p is going to be appearing in the right hand side. Okay. So always you need to take care. So let me take one example and how it is going to be multiplied. So many a times very small errors make it to be irritating answers. So now we'll have here a 3 by 2 matrix here and a 2 by 4 matrix. So at last we are going to get a matrix that is 3 by 4. Okay, we are going to get a 3 by 4 matrix here. Okay, maybe whatever it is, I'll just enter some of the numbers, some random numbers. 2 0. It has 3 rows and 2 columns, so maybe 2 0 is enough. Of 5 minus 1 0 2. Okay, now I have here 2 rows and 4 columns. 1 2 2 4 minus 1 0 2 minus 1 2 1 0 2. Okay, I have taken smaller numbers so that multiplication becomes easy for me. So how do I need to multiply this? This comes to be the question. So since it was only 2 rows, I think I got confused right by this one and that one. So we have 2 rows and 4 columns. So you have 8 elements here, you have 6 elements here, but 3 by 4 you need to get 12 elements. From how we are going to get the 12 element, we are going to see properly here. So the first element, what is going to be here? You had 12 elements. It is going to be of the type, it is of 4 columns, right? 1 2 3 4 1 2 3 4 1 2 3 4, like this. So many 12 elements are going to come. So first of all we need to consider where it is going to be. So it is going to be in the first column, first row, first column, first row. So here the first one you need to consider the row and the second one you need to consider the column, because this represents the row and this represents the column. Therefore you need to take row from here because this 3 has appeared here, and you need to take the column from here because number of columns 4 has appeared here. So for that, what we need to do? So we want the first element A1 1. I'm considering 1 because first row and the first column. So 1 and 1. So 2 into 1 is 2. First row, first column. That means I need to multiply every term here of the first row with every term in the first column. For that, I need to multiply. This is only the first row and first column. I need to consider only those two now. That is going to be 2 into 1 plus, you need to add here. So first by first, and there is one more element in the first row of here and one more element in the first column of here. So that's why you are going to get plus 0 into minus 1. Therefore it is going to be 2 here. Okay, now we are going to consider the first, this position. This position is A2 1, that is the second row and the first column. If you consider the second row, now we have 5 and the first column has 1. So it is going to be 5 into 1, that is equal to 5 plus, minus 1 into minus 1, because this is present in the second row itself and this one more element is present in the first column itself. Therefore you need to multiply that and add to this. You get 5 plus 1, that is equal to 6. 6 comes to be the entry here. So similarly you can do here 0 into 1 plus 2 into minus 1. 0 into 1 plus 2 into minus 1 comes to be minus 2 here. Okay, now we'll go to the second column. For the second column we need not think about this. Whatever is the second column, we need to just think 2 and 0 is present. So since 0 is here, I need not bother about the second column of this. So I need to just multiply 2 by the first column of this and just go out. So it is 2 into 2, that is 4. 2 into 5, that is 10. Then 2 into 0 is 0. Okay, now we'll go to the third column. Third column we need to bother only about this. So we have 2 and 2. You cannot leave out like the previous one. So we have 2, because it is in the first row, it is going to be with this. So 2 multiplied by 2 is going to be 4. And you have 0 multiplied by 2, that is 0 itself. So 2 into 2, 4 is going to be what is going to be remaining. And here similarly you are going to get 2 into 5, that is 10. 10 then in plus minus 1 into 2, that is minus 2. 10 minus 2 is 8. Okay, now we have one more, that is 2 into 0 is 0 plus 2 into 2, that is 4. I hope you understood how I have taken. I need to represent only this by the rows. So the row of this and the column of this should be multiplied. Since here you have 2 and 2, you will have only 2 things. You will not have anything extra. That's why you have this 2. That is the option. So only if this n is going to be existing, for which these two are having number of columns and number of rows to be equal, only then you can multiply this. So that's how you are not going to get any number that is left out while multiplying for getting for a number. Okay, now we have the first row and last is fourth column. So fourth column is here. So other columns I'll leave. You have 4 and minus 1. So you have 4 into 2 is 8. 4 into 2 is 8. 0 into minus 1 is 0. So it is going to be 8 here. Okay. Now we have 4 into 5, because it is belonging to the second row. I need to consider the second row here. So it is going to be 4 into 5, that is 20. 20 plus minus 1 into minus 1 is 1. So it is going to be 21. Okay. Now we have 4 into 0, that is 0. Then minus 1 into 2, that is minus 2. This is going to be the product of these two matrices. So if I consider this is A and this is B, this can be represented as AB. Okay. So the thing, while multiplying, you can understand that you are not going to have everything is to be same, because you are considering the row of this and the column of this. Therefore, even if you interchange this, you are not going to get the same, and it is not defined also, because it is 2 by 4 and 3 by 2. 4 is not equal to 3. Okay, if I interchange, I am telling, if I interchange is 2 by 4 and A 3 by 2. For multiplying, this number should be equal to this number. When this is not possible, therefore this multiplication is not defined. That is, you can just tell that matrix multiplication is not going to be commutative, nor it is going to be associative also. So if it is not commutative, most of the times it is not going to be associative. So here also it is not going to be associative. So we'll think what is left here is about non-commutativity, and the remaining property is that. But here you can find out that associativity can hold properly, even though commutativity is not. Alright. Okay. Property of associativity. This is the first property we're going to learn about matrix multiplication. Before this, we understood that it is not going to be commutative, so I'm not going to list it up here. So only associativity is very important here. So if I consider A into B into C, that will be equal to A into B into C. So we'll just check whether it is going to be have the proper order. I'll check in this case. So A, let me consider m by n, and B I'll consider n by p, and C I'll consider p by q. So at last what you're going to get the order, I need to just check. So if I multiply this, maybe I'll get another thing, another matrix that is of n by q. I need to multiply A into m by n. So maybe some y I'm going to get, n and n is going to get cancelled. It's going to be m by q. M by q is the order. We'll just check whether it is going to be the same order here. That was this one. So for this one, it is here. That is A m by n into B n by p is what you get here, into C p by q. Okay, from this you can get some x, not the same x, some other x. So m by p you are going to get, because n and n is going to get cancelled. So you get again C p by q, because p and p is here, you can multiply, you get some y, maybe the same, it is going to be m by q. Therefore, since the order is going to be the same, even the answer needs to be the same. Okay, that's how we can conclude that it is going to be associative in nature. Okay, the next part is the next property. Next property of matrix multiplication is about the distributive law. What is the distributive law? You might have learnt about the distributive law of multiplication over addition, and here you are going to learn about the same. So I can write that A plus B into C can be written as AC plus BC. Since A and B are of the same order, both of them can be multiplied by C, because that order has to be defined in both the cases. Or I can write it as A of B plus C is AB plus AC, because here I am considering the left side, because rows are considered in this case. Here the columns are considered in the case where of C. That's why there is two things. So similarly we can find also identity for the operation of matrix multiplication. We are going to learn about how it is going to be the identity. So I think you can try by yourself how you are going to find identity. Identity of the matrix multiplication is the identity matrix. Identity matrix, where it is a square matrix which is of the same order. I mean not the same order, it is considering the same order. So maybe I have this thing that is A 3 by 2. Then what will be the identity matrix that is representing, that makes it equal to A 3 by 2 is 2 by 2. Since this and this should be equal, that is A star E should be equal to A. Here also this is A 3 by 2. Since these two are going to get cancelled, this should be equal to this. But at last we are going to get the same matrix. Therefore, the last one also should be equal to this 2. Therefore, it is going to be an identity matrix, that is the square matrix over there. So every identity matrix can be used as an identity for the matrix multiplication. Okay, now I'm going to start with the exercise. That is exercise 3.2. Here the first question is all about addition, subtraction and such things is asked over there. So maybe you can do it by yourself, because it is just about addition, adding two numbers, or maybe multiplication may be difficult. You can do it yourself, you can just try that. So the second question is also about addition, so there is no problem with that. Now we're going to the third question. Third question, you are asked to find the products. Okay, and this one, that is the product, both are square matrices of order 2 by 2. Therefore at last you are also going to get a 2 by 2 matrix. Okay, so now you have first row and the first column that's going to compute. That is A into A, that is A square, plus B into B, that is B square. So that is going to be A square plus B square. Okay, here you have second column and the first row, that is A into minus B, that is going to be minus AB, and B into A. This is the second column, this is the first column, right? So this is B into A. Minus AB and plus AB is going to be 0. Okay, now we have B, that is the second row and the first column. That is going to be minus B into A, that is minus AB, plus A into B, that is going to be 0 here also. Now you have your second column and the second row and the second column. That is minus B into minus B is B square, plus A into A is A square. So it is going to be A square plus B square. That is going to be the answer here. Here you are going to get, this is a column matrix. Column matrix has only one column and 3 rows, and here you have 1 row and 3 columns. Therefore at last you are going to get a 3 by 3 matrix. Okay, in the first case you have first row and the first column, so 2. Second row and the first column, that is 4. Third row and the first column, this will get me 6. So in this is the second column, so I'll multiply by 3 by everything. That is going to be 3, 6 and 9. Similarly I'll multiply 4 by everything. You're getting 4, 8 and 12. This is going to be the answer here. Okay, now we'll find the order of these two. That is 2 by 2 is this one, and this is 2 by 3. Therefore what you are going to get is also 2 by 3 over there. Okay, you are going to get 6 entries like this only. So what is there in the first position is first into first, that is 1 into 1, plus minus 2 into plus 2, that is minus 4. 1 minus 4 is minus 3. Minus 3 is what you are going to get. Then here what you are going to get is 1 into 2 is 2, minus 2 into 3 is minus 6. So 2 minus 6 is minus 4. Then you have 1 into 3, that is 3. Then minus 2 into 1, that is minus 2. 3 minus 2 is 1. Then similarly you have 2 into 1. Let me do it a bit fast. So 2 into 1 is 2 plus 6, that is going to be 8. Then 4 plus 9, that is going to be 13. Then you have 6 plus 3, that is 9. So this is going to be the answer. Similarly you can also solve the 5th and the 6th subdivision. Okay, now we have a 4th question. Most of these questions in the matrix multiplication and whole matrices chapter is all about your own work. It's very simple. Only when it comes to the statement problems, it becomes a little bit difficult how to understand that, how to make the table or column and such things. So in the next question is also about the computing things and also verify the distributive law. Not the distributive law, it is given about how that it is commutative, addition is commutative, it is based on the property of that. Similarly, 5th question also you can find out. It's all about multiplying by a scalar, then subtraction. Subtraction, I mean the difference of the two matrices by adding to the inverse of that, like that. Not the inverse, additive inverse. Okay, now we have the 6th question to simplify. Now we have your 7th question. 7th question just is about multiplication and addition. So directly we can find out that it becomes cos square theta sine theta minus cos theta sine theta and cos square theta here. Again here it becomes sine square theta minus sine theta cos theta sine theta cos theta and sine square theta, because you are going to multiply sine theta by every term. So when you are going to add cos square theta plus sine square theta, just by your identity it is going to be 1. So now we have cos theta sine theta minus cos theta sine theta is going to be 0, minus cos theta sine theta plus sine theta cos theta 0, cos square theta plus sine square theta is 1. So you are going to get an identity matrix. Okay. Now we have a 7th, 8th, 9th, 10th. Okay. The 7th question is all about using any method for solving. So that forms a linear pair of equations in matrices. So you are just asked to find x and y. So directly you can use the elimination method or cross multiplication. Not cross multiplication, elimination method, that is the best one. So you need to add those two given equations and find out one of them So and so on, you can do the 7th question. So 8th, 9th, 10th, 11th and 12th, 8th to 12th are very similar questions. They're just about addition. So if you are adding, you are going to get some of the values. So equality of the matrices is all about every element should be equal. Based on that, they are given the questions. And there is extra, because you have learned about multiplication by scalar, there is some extra things that are mentioned in that also. Okay. Now we'll move on to the 13th question. In the 13th question, it is given all about another matrix. Chapter is about matrix. They are given about matrix. Okay. It is a function f of x. So we'll consider the matrix. The matrix is cos x, sin x, 0, 0, and this is 1, 0, 0. Okay, these two things are minus sin x and cos x. Minus sin x and cos x. You are asked to find out f of x plus y should be equal to f of x into f of. To not waste your time, I have written almost all the things. So here f of x, you have f of y. So I'm just writing. So I'm taking LHS. Okay, this was RHS. In the textbook it is given LHS. So LHS is equal to f of x into f of y. So I'm going to multiply these two things. So after multiplication, I am going to get this expression. Okay, you can multiply by yourself because it becomes practice. At the first it becomes very difficult, but so on later you can do it faster. So you get cos x cos y minus sin x sin y in both these two cases. So that is the identity for cos of x plus y. So what does this become? This becomes cos of x plus y. This is however 0. Okay, these two are also 0. Okay, now even this becomes cos of x plus y. Here you have sin x cos y plus cos x sin y. That is identity for sin of x plus y. Similarly, you get here minus sin of x plus y. Generally, when a proof that question comes, somehow you need to get that answer. That's it. Okay, next you have the 14th question. 14th question is given that the multiplication by matrix multiplication is not commutative. So just you are wasting time on that. If you want, you can just multiply and see, because that's a very big matrices. So I prefer not to do that. Okay. Next question is about 15th one. You are asked to find a square minus 5a plus 6i. What is the a given here? Many times when it becomes it becomes wrong if it is wrong while writing the matrix itself. Okay, so this is 2 0 1, 2 1 3 and 1 minus 1 0, 1 minus 1 0, and what is asked in the question is a square minus 5a plus 6i. I refers to that which is of the same thing. So when you consider a square or a cube, always you need to take care that it is defined only if it is a square matrix. Here you have a square matrix of 3, order 3. So therefore you are going to have, first of all we'll find a square. A square is same as a into a, right? So I'll find out that is 2 0 1, 2 1 3, 1 minus 1 0, same thing, 1 minus 1 0. Okay, now you have to multiply. That comes to be 4 plus 1, that is 5 here. Then when it comes to here, that is 0 plus 0 plus minus 1. Okay, then you have 2 into 1 2. Okay, then you have 2 into 2 4, 4 plus 2 6, 6 plus 3 9, 9 is what you are going to get here. Then you have 2 into 0 0, 1 into 1 1, then minus 3. So 1 minus 3 comes to be minus 2. Then you have 2 1 3 and 1 3 0. Okay, so 2 into 1 is 2, 1 into 3 is 3. So it's going to be 5. So now we have 1 minus 1 0. That becomes 2 minus 2. So this everything is going to be 0 here. Then you have this is going to be multiplied by 0. It's minus 1. Minus 1. Then you have 1 into 1 is 1. Then minus 3. 1 minus 3 is minus 2. This is a square. So we need to find this expression. Therefore, you need to find a square minus 5a plus 6i. That is going to be how much? So it is going to be 590 minus 1 minus 2 minus 1 2 5 minus 2 plus minus 5 times that thing. So I'll multiply and write it properly. Okay, there itself I'll multiply and write. That becomes 10 0 5 10 5 15 and 5 minus 5 0 plus 6 6 6 and remaining things to be 0. This is going to be just what you need to add in this case. So you are going to get a 3 by 3 matrix here. So that is going to be 5 minus 10 plus 6. 5 minus 10 is minus 5. Minus 5 plus 6 is 1 here. And then you have minus 1. Here it is 0, no problem. So minus 1 itself. Then you have 2. 2 minus 5 is minus 3. Then you have 9 minus 10 is minus 1. So you are going to get that. Minus 2 minus 5 is minus 7. So you are going to get minus 1 here because there is 1 6 over there. Then you have 1 0. 0 minus 5 is minus 5. So you're going to get minus 5 here. Okay, one more left. 5 minus 15 is minus 10. Then you have minus 1. Minus of minus 5 is minus 1 plus 5 or 4. So 4 is going to come here. Then you have minus 2. Then this is 0, no problem. Minus 2 plus 6. That is going to be 4 again. Okay, this is what we are going to get as the answer for the given expression, that is a square minus 5a plus 6i. Okay, next we'll move on to the next question. The next question is highly complicated because you have an e cube that becomes highly time consuming. Therefore, I'm not going to do that. Okay, so the next one is about very similar to this 15th question because it is a square is equal to ka minus 2i. There only the thing is, extra thing is, we need to find out the variable k, value of the variable k. Okay, next you have your 18th question. 18th question is also very similar, so I think I did not do that. Next I'll come on to the 19th and the 20th question. Okay, they are important because for the first time I'm going to do about the statement problems. Okay, let's see what is the statement problem that we are going to get now. So it is given, you can see the question here. A trust fund has rupees 30,000 that must be invested in two different types of bonds. The first bond pays 5% interest per year and the second bond pays 7% per year. Okay, using matrix multiplication, determine how to divide this amount is 30,000 rupees into two types of bonds if the trust fund must obtain an annual total income of this much. So income refers to this thing and you are going to get extra. So I hope I need not write the statement and all, because even though it's a statement problem, I'm going to do in the first part, that is 1800. So I need to have two matrices for the principal and the rate. I need to make it in such a way that their product is going to be a unit matrix. Not a unit matrix, I mean a matrix of unit order or order 1 by 1. Okay, now we need to take it for two things. So let me take it to be a 1 by 2 itself. Okay, and this let it be 2 by 1. So the rate is given to be 5% and 7% respectively here. Then you have your P, where there are two types of bonds. Okay, you are not given how much is going to be given to each type of them. So I'll take that amount that is given to the first one is X. Therefore the remaining money, that is 30,000 minus X, is going to the second one. Okay, if I multiply this, what I'm going to get is X into 30,000 minus X into 5 by 100 and 7 by 100 is going to be, you're going to get only one thing. Okay, that is 5 into X by 100 plus 30,000 minus X into 7 by 100. Okay, by taking LCM I can find out that 1 by 100 I can remove out of that matrix. So it forms 5x plus 7 into 3 is 2100, or I can call 2,10,000 minus 7x. Therefore you are going to get only minus 2x here. So but it is given in the first case that it is going to be 1,800. So we'll just equate it to both of them. So what it is going to be is 210,000 minus 2x is equal to 1,800, and these two zeros I'll take and multiply it by 100. So this is going to be the number. So we'll take this to the right hand side, bring this here. So I'll write it here now. So 2x will be equal to, you have 4 zeros in both the places, so 21 minus 8 is going to be 3. So it is going to be 3 followed by 4 zeros. Therefore x is equal to 15,000. Therefore he has to, or the trust has to fund 15,000 to the first one and the remaining, that is again the 15,000 to the second one. Similarly you can do the second part also, where it is given that you need to equate it to 2,000. That is the only difference, you need to equate it to 2,000. Okay, now we have your 20th question. There is also a statement problem. Okay, this is very similar to this question only, but here you are going to have three things, that is chemistry, maths, and one more subject, that is physics. Okay, this is the 20th question, right? Okay, the question you can see here. The bookshop of a particular school has 10 dozen chemistry books and 8 dozen physics books and 10 dozen economics books, not maths books, economics books. Their selling prices are 80, 60 and 40 rupees respectively. So find the total amount of the bookshop will receive from selling all the books using the matrix algebra. Matrix algebra, I mean you need to use the matrix multiplication. So the first thing, I need to make two matrices and then multiply by using algebra of that. So I need one column matrix. First of all I need a row matrix that is going to have 3 because it is of 3 types, and first we'll enter the number of dozens. Here it was 10 dozens, then it was 8 dozens, and again 10 dozens. Okay, this is the number of books. This was chemistry, physics and economics. Okay, now we'll form one 3 by, this was 3 by 1, right? So maybe I'll make this to the left side because I want that one answer only, indirect. So what was the cost of each dozen of book was 80, 60 and 40. 80, 60 and 40. This is for chemistry, physics and economics. However, when you are going to multiply, you are going to multiply 80 by 10, 60 by 8 and 40 by 10. So first of all you need to represent it in this form, and then you need to mention which is chemistry, physics and economics in the question. This is 1 by 3 and this is 3 by 1. So you are going to get only one number. Let me make it big so that I can write all the things. So 80 into 10 is going to be 800 plus 60 into 8 is going to be 480. Okay, then you have 40 and 100, that is 400. So what will be the total is, leave the last part. So you have 8 plus 4.8 plus 4. 8 plus 4 is 12. 12 plus 4 is 16. 16.8. So it will be 1680. That's what is going to be the earning. This is going to be the earning by selling all the books. Okay. Next you have the multiple choice questions. So you need to read that very carefully here, because it is dealing with the orders and how it's going to multiply. 21st and the 22nd question. So there are 4 sets, that is X, Y, Z and W. So they are going to have the orders 2 by N, 3 by K, 2 by P and P by K respectively. P by K. This much is over. You are not only bothered about the orders now when you are thinking about multiplication, whether it is possible or not. Only that much is the question here. So the restriction on N, P and K such that PY plus WY. Okay, PY. Oh, P was missing. Where did it P go? Okay, this was for P. And this is N by 3. Yes, so you need to find PY plus WY. For that, this is P cross P by K. Then you have Y has to be 3 by K. So that means that if it has to be defined, K should be equal to 3. Now we have this, that is N by 3 and W is 3 by K. Therefore it is matching. There is no problem here. K is equal to 3 is the first condition you are bothered about. Then if you need to add these two, that means that you need to have the same. So the product which you are going to get, if K is equal to 3, will get P cross P by K. Here you are going to get N by K. K and K is identical. If we need to add, it should be of the same order. Therefore N should be equal to P is the second case. And these two cases are present in the option A. Okay, option A. Now you have your 22nd question where N is equal to P is given. Okay, then you are asked find the order of the matrix 7x minus 5z. 7x minus 5z. And it is given that N is equal to P. So what will you find the order of x, nx and minus z? So if it is given N is equal to P, therefore it is be of 2 by N or 2 by P. Because scalar multiplication doesn't matter, so it is going to be difference, therefore it is going to be simple addition only. Therefore since N is equal to P, they can be subtracted from each other. So their sum or the difference is going to be the same, that is 2 by N or 2 by P. One of the options is only 2 by N is present, so I can take only option B, and there is no option with 2 by P, therefore I need to leave that point. Okay, in the next topic we are going to learn about the transpose of a matrix, and based on that we can think about symmetric and skew symmetric matrix.